linkages. In general, linkages are a method of moving power from one input to another to the output. And usually, for the context of this course, we'll be looking at 4 bar linkages, which is basically having that name because it has 4 bars. So this is a common example of a linkage. So you can
4 bar
see
linkage.
the supports are usually called A0 and B0, and the positions A1, B1, and if it changes, A2, B2,
Me too.
so on. So the main thing what we are doing here, let us look at the main components first. AB is
Mm.
called coupling, A0, B0, this is called the frame, and these are called limbs or joints. Okay.
Okay.
Usually
A and
everything
B
you
had.
see in this course will be some kind of combination of this 4 bar linkages.
I just want to ask something like A and B are fixed on the ground.
Yes, A0, B0 are fixed, A1, B1 are moving.
Okay.
And we have a couple of different types of questions. I will start with the basic one first, but before that, just
Mm.
reminding you that questions will be some kind of a mix of 4 bars. Basically, what we usually have is you will have let us say we know the angle it is changing. This A0, A1, let us say we know it is rotating by 10 degrees. How can you proceed from there?
No idea. No idea.
So the first thing is to draw the new position of this to draw position of A2 because A0, A1 the length is fixed. So the same L is here and we have this position. And this B0 is also fixed. That's not going to move, it's on the ground. But what we don't know
Mm.
is B2.
Mm.
But we know one thing, this B2 and A2, that distance does not change. Let us say that is M, this is always M, and this B1, B0, let us say that is N, this is also N. So what we do from A2, we can take a circle of radius M, let us say this is A2, and let us say this is B0. We make a circle of radius M, and from B0 I make another circle of radius N, and the point they intersect, that will be the new B2 point. And you can see these circles, they have two intersecting points, but it's quite easy to guess that this B1 is going to go here and not there, right?
Mm.
So now let me solve
And
an actual example question. Now that the basics are out of the way, I'm going to use SolidWorks to solve. So the question here is, if the cylinder in the dump truck shown below is extended to 1.5 times the length it is now, draw the position of all linkages and joints and sketch the container in that position. So let
what?
us label the points. Can I draw on this? No, I cannot. Let me insert some text. Let it be for now. So look at this cylinder. I've already marked the points. This is the one end of the cylinder. This is the other end of the cylinder. Are you able to see those points?
Yes, can I quickly download this?
Download what?
This question.
This file should be under the question linkages on Moodle, or I can send it on WhatsApp now. So the cylinder
According to
is
my scale,
initially, we have these 2 points marked here, the end points of the cylinder. It's going to expand and become 1.5 times, and that is basically 47.67 millimeters. And
according to my
between the
okay, so
and this
one
cylinder
second
end
here.
point here and this B naught point is going to be constant. So let me measure that. So we'll take the distance along the line. It's 24.45. So we have the cylinder length, and this length here is 24.45. Okay, good. Now,
Just a moment, please.
okay,
Just a moment. I'm still I'm calculating the length here. According to my calculation, my scale, I'm getting 2.3 centimeters.
yeah, that's all right. But let me. The procedure is the same, right? Let me continue.
Okay.
So the first step is to make a circle with the center as A naught. This is the A naught point, and radius as 47.67 millimeters. Yeah. So sorry. Make some circle. Smart dimension. Ooh. It's too big. The text. So I will set the length, that the radius as 47.67. Okay. So that will be where the end point of the cylinder can be, but in some orientation, we don't know what orientation. Next step, we take this point as center and keep the same radius, because these two are on a rigid piece of steel. They are rigid. So the distance between these 2 points cannot change. So we can do that. The distance is 24.45. Right. And you see this intersection point, that is the new location of the cylinder.
Okay. Oh.
You see this line here, that will be the new end point of the cylinder.
Okay, so
Maybe this was not a good first question, but okay, let us continue. So now we have the end point of the cylinder. The next step will be to get this point, because this is the B1 point which we actually need. So we do some more measurements. First I'll drop a point in the position. It's not perfect.
B1.
This is B1, correct. Yeah, better. So now I will measure two more lengths again. Let me make a better drawing here. So we have that. We have this. And then we have the cylinder. So cylinder A0, B0, B1, A1, and these two are combined by the dumper, the bucket, right? Now I can measure the distance of B1 from the cylinder endpoint C. So CB1 can be measured and B0 B1 can be measured because they are all on the same rigid structure. They are not going to move with respect to each other. So let me start with CB1. Distance is 73.8
Which distance are you taking?
between
The
C,
total one.
the original in the initial position, C to B1, and then I will take B0 to B1.
No, I'm asking like the distance, like the whole distance, like the diagonal line
Yeah, the
or
diagonal
the
distance, because that's
horizontal.
what you would do in real life, not the x or y distances, just the actual distance between the
Okay.
2 points.
Okay.
And then I take one more distance, it's 96.38. I will take it as 96.4. Alright. So now we need to find the new location of B1 using these calculations. So just like I did previously, I will make circles. So the first circle I will make with this center B0 B1 and radius 96.4, and this one is just going to pass through here, so I can just do that, and it's going to be there somewhere else. The next one we do from the new C point, because the old C, if I do that, I will get again the same existing B1 position. We need B2, so I will take the C2 point instead of C1. Let's say C1 and then C2. So from the C2 point I am taking the radius. Radius is 73.8. 73.8. And you can see there are two intersections. One is on the left side and the other one is on the right side. If you are going to push this cylinder outwards, this bar is definitely going to move to the right side. So we will use this intersection point. Clear?
Mm. But mm, I'm a little bit confused. Okay, like carry
Why?
on. Let's see.
Why are you confused?
Uh, mm,
Of course, when you draw on paper, you don't need to make this whole arcs, just whole circles, just make the arcs for the relevant area of interest. So I know the cylinder is going to be somewhere here. So I will just make arc from say here to here, not the whole bottom side.
mm-hmm, mm,
Yeah, so this is the new B2 point.
mm.
Okay, now what is your question?
Like I'm still trying to understand. It's too complicated for me. Okay, so first, like this is I'm still at A naught B naught. So you did A naught, and then you multiplied the length of the cylinder by 1.5,
Yes.
and then you drew a circle around it,
No,
around
around the
around the
A naught
center
point.
A naught.
Exactly, that
Yeah,
is this circle.
with the new length,
Yes,
with the
new length.
new length, and you drew a circle
From
with
the B naught
the
point.
B naught C1,
Yes,
B
exactly.
naught
B
C.
naught C1, and that distance does not change. So I just drew a circle. B naught C1.
Yeah, and then it gave you an intersection which will be the new point of the cylinder.
Exactly. C2.
Okay, then you then whatever then you calculated two distances,
Yes.
CB1
B naught
and
B1 and
B
C1
naught
B1.
B1, and you draw one circle around C and one
Wait, don't
circle
say
around B
C.
naught.
Say specifically C1 or C2. C1 is
around
the initial portion of the
C1.
cylinder and C2 is the final portion of the cylinder.
Around no. So I think you drew one circle around B naught and one circle around C1.
No, if I draw around C1, just the original point,
Hmm.
I will end up getting the B1 point, which I already have. There's no use in doing it. So I do it around the C2 point so that I can get the B2 point.
Hmm. See. Okay. Just okay. So if I okay. So if you want to calculate A2, you will take the distance from A naught to A1 and draw that circle around C2.
No, why will I take it around C2? C2 has nothing to do with A2. Their distances can change. For any one point, we need two references. So for A1, I can use A0, that is perfect because they are on the same bar, their distances are not going to change. What other reference can I use?
Uh, 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 B2.
Yes, A0
Sorry,
can be
B1.
used and
B1.
B2 can be used. So that is exactly what I will do. So A0,
B you will draw one circle around A naught and one circle around B2,
yes,
the new B.
yes. And for that
But
radius, I
the
will use
distance
the
of
B1 A1 radius.
okay. It's too complicated.
Let me drop a point
Okay.
there. Measure
I have to
distance.
get some compasses and I have to get
Yes,
some
yes.
compasses and stuff like that. It
So that is
so you,
the, but usually on the paper you don't need to write the lengths. Basically, put down your compass needle here, extend the pencil till there, and just use the radius. And the professor, he can see where you have made the holes, so he grades based on that.
one question.
Yeah.
One question.
What is your question?
So the question is for the A2 part, A to determine the location of A2,
Yes.
we took the distance, the normal distance, or I mean, the main distance between A naught and A1,
Yes.
and draw a circle around A naught, right?
Yes.
Okay. And then we took B1 and A1 and draw a circle around B2.
Perfect.
Then we will get an intersection,
Correct.
and that will be point A2.
Correct.
And for B2, we draw one circle around B naught and
Hmm.
one circle around C2.
Yes.
But and for for the location of B2, we took one distance of B1 B1 C1
Yes.
and one distance of B1 B naught.
Yes. Okay, let me proceed. So I need to measure A1, B1. Why do I have 3 points anyways? Okay, new
Oh,
measurement.
wow.
46.1.
Too, too hard.
So 94.8 millimeters around A naught. So this is A naught. I will make a new circle. Okay, that is passing, should be passing through here. Why is it not? $94.8. Okay, okay. So basically like that, yeah. So this circle is passing through the A1 point and it will pass through the A2 point as well. Right. Now we need one more circle from B1 A1. No, from B2. B1 A1 we measure the distance and we make it around B2. Just a moment. Where is my cursor? Here. So this is the B2 point. I will make the circle 46.1. Alright. Now you have to remember which circle is which. So this is the circle you are looking at. When this goes to this side, when this one is pushed away, that the dumper is kind of going to tip over. It's going to move in this direction, which is going to put and kind of push the A1 point to the left. So this will be our new A2 point. It won't go here, it will go there.
Why?
What do you mean why?
Shouldn't it go to the right?
No, it won't go to the right because the cylinder is pushing the B1 point to the right. That much is clear. And since B1 is pushed to the right, the whole thing kind of rotates. Like it rotates,
Mm-hmm.
the bucket rotates. This whole thing is the dumper bucket. That thing will rotate, which will push this A1 point to the left, which means it's more likely to, it's going to be here, not there. So basically this is the A2 point, this is the B2 point. Clear? And now we basically
I'm
have
trying.
everything. We just need to sketch the new points of the limbs, sketch the new cylinder. We already done the new cylinder. And then we need to use these points to draw the new bucket position. So notice one thing, A1 was here and then it went there, and B1 was here and it went there, which means the bucket has completely turned. One moment.
Hmm.
Oops, sorry, my bad. Just give me a second.
Okay.
I solved this in class as well, so I'm just checking that solution. So the B2 point is definitely correct, but the A2 point is wrong because then the bucket would be upside down. Yeah, because if I continue, this was B1 and this was A1, and for it to be flipped, the bucket has to be upside down on the top of itself, which is wrong. Right? So this should not be A2. I was wrong. Instead, this point here, this should be A2, like you said. I made the same mistake in class as well. So basically, I said
Hmm.
initially this was the A2 point, but then if you look at it, the whole bucket would be upside down. So that's the wrong position. So let me.
Uh, can I share my screen?
One moment. Let me finish this.
Hmm?
Let me finish this. Let me mark the A2 point. Yes. Okay. Pause. So continuing. This is the A2 point, this is the B2 point, just where we left off. Now let us draw the lines to these points. So this is B2 goes there, and this is A2 goes there. And based on this, we need to sketch the new position of the dumper. I would like to do something like that. Yes, let's see. So basically now we have everything. We have A1, we have B2, we have A2. So the whole dumper basically moved to the right and there is no flipping or anything. It's just tilted and the materials have fallen off. Now I need to draw the new position of the dump truck, of the dump bucket. Okay, let's see. I will be a happy person if this works. So in the exam, if you have time, sketch it properly with scale and pencil. If not, just draw the rough one for the outer, for the bucket.
Okay.
Because usually you won't have time to do that. So just draw it roughly. Now let me move entities and select arc 9. That one, that one, that one.
Oh, you're doing it on SolidWorks.
Yes, yes.
Nice.
I need to rotate it as well. One, two, three, four. I think that doesn't work. So basically, in the paper, when I solved it, what I did was I looked at the distance of this corner point from B1, and with the same distance and orientation, because the angle between the A1 B1 line and the outer part of like the outer edge, they're basically parallel lines.
Mm-hmm. Yeah, I got what you mean.
Yeah,
I
so
think
I
I get.
used that as a reference to move the dump truck, to move the bucket.
Okay.
From to, let's say somewhere here. I have to unfix it. I can't
And
undo.
I was thinking one thing.
Mm. Yes.
Yeah. So what I was thinking was like maybe we should, if it's okay with you,
Mm.
maybe we should do the linkages part at the end when I'm back in Germany.
Okay, we can do that as well. But let me
Because
finish this
then
one.
yeah, no worries. Because then I can come to you and I'll have like pages and everything so that you can you can like I understand it. What you mean,
Hmm.
but then I'll be able to solve it in front of you.
Yeah.
Right now, I don't think so that I can solve it on the iPad. I have to print it out. There is no like
It's not quite the
no.
same, but you see, this
Yeah,
is
but
what you
I
do.
yeah. Mm,
And then I can add relations, let us say. I will try. Insert relations. And good. And I can measure another distance just by putting a point here. Okay, evaluate, measure, distance. It's 18.9, and I will use the same distance here. Sketch, smart dimension. Yeah. So this is the new position of the dumper. Yeah, some things got messed around, but that's how you do it. Okay, then we'll stop linkages for now.